Hi everybody, welcome to the 2.7 linear piecewise functions video. Sorry I can't be with you today in class. Hopefully this video helps. If you have questions, please just make a note of them on your notes and I will be back with you next class to go over this. Okay, so you should have seen some piecewise function graphing and evaluating in previous classes. If this isn't familiar to you, don't worry. We're going to be sticking with strictly linear functions for now. And so piecewise functions are functions that are defined by more than one equation. And so if we think about real life, more often than not, we have multiple phases of things happening. For example, parking in a parking garage, it might be cheaper the first hour or two or given time period and then it gets more expensive. Or library fines, they're cheaper for a while and then they start getting more and more expensive. So those would be a couple of examples. There's lots of other things. The price of an item, it might be cheaper until you buy a certain amount and then it gets even more cheaper, things like that. So this would be considered a piecewise function. This is considered a piecewise function because it's made of two individual pieces. And the individual pieces are defined by this part right here. This is the domain. Okay, and the domain tells us the x values for which this specific function applies. So for all x values that are less than or equal to 1, we would use this equation. We would graph that equation, we would use that equation to evaluate. If we had an x value that is more than 1, we would use this bottom equation. So whenever you want to evaluate, which is what we're going to look at first, when you want to evaluate, you have to determine what domain, which of this part right here, does your x value fit in. So for example, if we look at the first one, x equals 0, that would fit in here to this top domain. If I think about x equals 2, that means I need the one that is equal to 2. And because this bottom equation has that equal to line, I would plug in there. And then if we looked at the 4 is more than 2, so I would again plug it in there. So if we look forward, we can see that we have these being evaluated. So like I had mentioned on the previous screen, okay, I think I did it in red, this x equals 0 would fit in the top domain because x is less than 2, 0 is less than 2, and because 0 is less than 2, that's the equation I plug it in. So you can see that we take 0, replace x, 0 plus 2 would be 2. As mentioned on the previous screen, if x is equal to 2, that would be this bottom one because that's where it has the equal sign. And that would be this math here. And then again, the 4 fits in that second domain as well because 4 is more than 2. And so that's why we would substitute it in there. So let's go ahead and do some examples. Okay. So we can see that the first example we're going to work through, we have the function f. So here's f, and here's our values for f that we're trying to find. So if I look at trying to evaluate f of negative 4, I need to pay attention to that negative 4. Negative 4 is less than negative 2, right? I would rather have negative $2, negative $4. The number that you pick is always bigger with money. So if I think about that, f of negative 4 would be 5 times negative 4 minus 1. You can see that all I'm doing is replacing x with the value that I have in parentheses. 5 times negative 4 is negative 20 minus 1 is negative 21. So we keep going. Negative 2. Because it needs to be equal to negative 2, I'm going to choose the bottom domain. The bottom domain is where it is equal to negative 2. Okay, so that's why I'm allowed to plug that in there. So f of negative 2 would be negative 2 minus 9, which is negative 11. 0. 0 is more than negative 2, which means it applies to the second domain. So f of 0 would be 0 minus 9, which is negative 9. And then one last example for our f problem, f of 5. 5 again is more than negative 2, so f of 5 would be 5 minus 9, which is negative 4. And so if you feel like you're confident in this and you want to give it a try, go ahead and pause the video and then you could look turn it back on to look at the answers for this next part. If you feel like you need more help, don't worry. I'm going to walk through the next ones with you. Okay, so we're looking for h of 1. So here's my h function. 1 is less than 6. That means it fits in the top domain. So to find h of 1, I'm going to do 1/2 times 1 minus 10. 1/2 minus 10 would be negative 9 and 1/2. Okay, so it's 1/2 minus 10 is the same thing as 10 minus 1/2, and then switch the sign. Okay, so if we keep going, let me see what colors I could use. I haven't used black yet. Negative 10. Negative 10, similar to 1, is also less than 6. So h of negative 10 would be 1/2 of negative 10 minus 10, negative 5 minus 10, which is negative 15. Okay, let's keep going. Okay, we have h of 6. So because it is of 6, it's important that we look at these notes, this notation. And so of 6 means I need it to be equal to 6. So yet again, I'm going to use the exact same one. 1/2 times 6 minus 10. That would be 3 minus 10, which is negative 7. One last example here for evaluating. Okay, it's asking me for 0. Again, 0 is still less than 6, so I'm going to plug it into the same equation. 0 minus 10, which is negative 10. Okay, so hopefully that gives you some insight on how to evaluate. Remember, all you're doing is plugging numbers in. The only additional step with piecewise functions compared to all the other types of functions that we've worked with is you have to determine which part that x value fits in. So really all you need to do is figure out where it fits in and then plug it in and simplify. Graphing. Okay. Graphing usually freaks people out, and what I'm going to recommend to you is if you do not have a pencil, you need to pause the video and go get a pencil. Okay, this is not something I would recommend doing in pen. You're going to see me doing some erasing here as well. Okay, so the first step I would do when I'm trying to graph a piecewise function is I try to make sure my domains are arranged. And I make sure they go from left to right, meaning negative 1 on the x-axis, which is right here, and then I have negative 1 to 4. So if I look at negative 1 to 4, that would be negative 1 to 4. And then if I look at the next part, it's 4 on. So I can see that these are in order. Okay, so when it's less than negative 1, that's this whole chunk. And then I have my middle chunk, and then I have a right chunk. Okay, so now what we're going to do, the next step is we're going to graph piece by piece. And I'm going to put erase in there. If you like to do this without having to erase, you're fine. Okay, we're going to graph the equation like we always have. So if I want to graph this equation here for this top domain, in this linear equation, this is my slope-intercept, or this is my intercept and this is my slope. So if I start at negative 3 and I go with a slope of negative 2, that would be down 2 over 1. And then I'm going to go up 2 over 1. So let me count, make sure I count my boxes correctly. Right, counting boxes is supposed to be the easy part. So let's make sure we get those points. Okay, so you can see that this would be my line. And again, my line's a little wonky because I don't have a ruler. So if you need a ruler, you might want to do that. But here's the part about a piecewise function. It's not all the way through arrow to arrow. It's only in this blue part. So if I look at that blue part, it intersects my line right here at this negative 1. So the first thing I'm going to do is get a small eraser and erase all the rest of this stuff. Okay, so now you can see that I need this part, and I can put an arrow at this part because the blue goes all the way to the edge of the paper. Okay, so then I need to look at this domain, and this arrow specifically. Because that arrow does not have a line underneath it, I need an open circle. So I'm going to just carefully erase my starting point, and I'm going to replace it with an open circle. Okay, so that means my blue part is done. Now I'm going to go ahead and graph this middle part. And so that middle part would start with an intercept of 4, and then has a slope of -1, which means down 1 and over 1. So I'm going to fill in a whole bunch of dots. And as you can see, I kind of know I need to start stopping there, but I'm going to go a little further just for the purpose of this demo, where I kind of put all of my dots out there. So if I was to connect this with hopefully a little bit straighter of a line, but I don't think so. Okay, you can see that I messed up my line a little bit. So let's see if I can get it to erase a little bit better. All right, here we go. Let's try this. Oh God, that got even worse. Sorry, guys. This is, okay. Sorry, I'm experiencing a little bit of technical difficulties, so hopefully we can make all of this work. Okay, so still using my orange pen, we can see that I need to have a filled in circle at 4. That means everything that's not between 1 and 4 needs to go. So that's why I'm erasing everything that's not between 1 and 4. And so now, because I've restricted my domain like I was supposed to, the orange line is done. So now all I need is the green line. And if I look at the green line, it starts with a slope of -1, or excuse me, an intercept of -1, and it would have a +1 slope. Okay, so I'm going to draw my dots. Okay, and so if I look at what I have going on here, right, this line would more or less go right through here, and I'm not going to draw it because it'd be really hard to erase, and I'm already having some computer issues. Okay, we can see that I need to go to the right of 4, and I need an open circle at 4. So I'm going to erase my dot at 4, and I'm going to replace it with an open circle around that point. And because I'm going to the right, I'm going to connect the line that heads towards that green part of my domain up at the top, and then I'm going to erase all the other unnecessary dots. And that would be my piecewise function. Okay, so I'm going to go through a couple more. So this one only has 2 pieces, which is helpful. It's a little bit easier to graph. So I'm going to go ahead and break it into 2 pieces. It doesn't matter what colors you use. I'm first going to look at my domains. So my domain goes from 1 over to the left because it's less than. That's this part. And then if I look at the other part, this would be from 1 to the right. Now, these domains do not have to touch. There may be a point in time where there is a gap, and that's okay. It's still helpful to outline them up here at the top first. Okay. So, my purple equation. It starts at a y-intercept of 4, has a slope of -1, which means I go down 1 and right 1. And so I'm going to just put some dots out there. You can see that I'm just kind of putting some guiding dots to kind of help me know where my line's supposed to be. When I look at this domain, okay, I know that this needs to be an open circle because of this arrow. It doesn't have the line underneath it. So I'm going to use my eraser, erase at the point 1, and then I'm going to draw in an open circle at +1. And my line needs to go left because, oops, that was a really bad line, because it's to the less than side. So that's why I'm going to draw on that part, and then whatever I have not used, I just erase. Okay, so now we go ahead and look at the second part. This would start with a y-intercept of 1, and then it moves up 1 because it has a positive slope. Okay, so at 1, I have a filled-in circle, and those circles can touch. An open, closed circle always overrides an open circle. And then I can see that I need to go this way because my domains should not overlap. If my domains overlap, then this doesn't pass the vertical line test and it's not a function anymore. So remember that vertical line test that you've been taught a few times, and that should not overlap. Okay, let's do a couple more examples. I'm going to outline my domains here. So I'm at -1, moving over, and then I'm going to have a middle chunk which is -1 to 3, -1, 2, 1, 2, 3, and then work that off. And then I have an x is more than 3, and that would be this part. Okay, so I'm going to start from the left and work to the right. If I start from the left, it starts with a slope or a y-intercept of -2, and has a slope of -1, so I'm going to put some guiding dots, kind of going both ways. And so when I look at my domain, I see that I'm supposed to have a filled-in circle at -1. So I find -1 on the x-axis, make that a nice big dot, and because my domain goes to the left, I'm going to draw in as straight of a line going this way as I can. Okay, any dots that are unused, that are still in blue, I'm going to go ahead and erase. Now we look at the green line. It starts at +4, has a slope of -1. I don't know why that was the function of the day today, but evidently that's the equation I really liked when I was making this. Sorry. Okay, so if I look at where I'm at, you can kind of see where my line is supposed to be. At -1, I'm going to have an open circle. So I'm going to use my eraser, erase my dot at the -1 part on my x-axis. I'm going to replace that with a nice open circle. And then at 3, find 3, I'm going to put a closed. That one is closed because it has that equal to line. I'm going to connect those. And any green dots that I haven't used, I go ahead and erase. And one last equation here. We have x plus 1. So it starts at +1, and then it just kind of goes up 1 over 1 because the slope is 1. So I drew in some guiding dots. We can see at 3, I should have a nice open circle. So I'm going to transform that into an open circle. And then because my domain is more than, it means it goes to the right. So I draw in my graph going to the right. Any orange dots that are still there that I haven't used, I go ahead and I erase.